Okay, so this is the fifth week of this online tutorial of Foundation of R software, and I am the tea instructor Kamla Mishra from School of Mathematical and Statistical Sciences IIT Mundi, and the course instructor is Professor Salav from Department of Mathematics and Statistics IIT Kanpur. Just okay, okay. So, in the last class, we have seen that in the fourth one, relational and logical operator, or maybe logical test. Okay, so here we have seen that in the lecture, as you can see directly from here, that there are and double end, and it is like this. So the shorter one and all. Okay. Okay, so if I go to the last class, just for the logical one, we can see that for one, it is behaving the same for both. If I'm just taking one value instead of a data vector. If I'm taking a data vector, what is happening? Uh, if I'm using the one end, it is giving me the correct result. If I'm using the two n sign, then sorry or sign, then it is giving me the error, and that this is the something like that. Okay, this is the problem. Whereas if you go to the lectures, and then you will see that if you are performing, if you go to the lecture, you can see that if you are performing, let's say, let me just copy this. Okay, okay. So if I will do it like this, okay. So in the lectures, you can see if it this is happening, then it is giving us the whole result. If all are true, then it is giving us true, and if all are false, then false, and something like that. You can see. Whereas now, when we are doing, it is giving us error. Okay, so why it is happening? So it is giving here. So there was a news um, here. So when you update the R versions, what it does is that it basically whatever problems it creates, or let's say you are getting some results which you do not want, or sometimes that when you have the new versions, then it just removes some unnecessary also work. So if you go to this, and if you will just go through this in new feature somewhere, then you can see that calling double N or double or with LHS, or if evaluated RHS of length greater than 1. So here we have length greater than 1, which is 3. it is uh, if this is happening, then it is going to show an error. An error is like this, so which we can see that we are saying that length 3 or length 4 or whatever length you will give, that this is the error. So you can see that it after changing the manuals, when we change the versions, then there is a change in manuals also, and according to that, it works like that. So I don't know where exactly it has written, but I have found this from this. So okay, anyways, so you can go through this and you can find some other changes also which has happened with this version. Okay. So in the last class we have gone through these logical vectors, uh, and also if anyone have any doubts regarding the previous classes they can ask. Otherwise we will move to uh, some new topics of today's lecture. Okay, so you can ask now, you can ask later or in between the class, that is not an issue. Okay, so no problem. Very nice. Okay, so today we will see what is how do we handle the missing data, and after that we will see the control structures. Okay, so missing data. Now, missing data is basically whenever you will have some real data analysis, uh, any kind of data. Basically, if you have, because if you have lidar data, let's say signals and weather, anything, or stocks even. So there are high chances that you will always have some kind of missing value. Now, depending on the percentage of missing value, we handles the data. Okay, so if let's say missing value, let's say there are thousand of location and there is one location in between where most of the time data is available, but sometime it is not available, then we will uh, interpolate. Basically, we will put some data in place of it, so that it it will not look like that it is something different. So basically, based on some other, let's say 999 location, and uh, also its data, its previous data, its future data, so we can fill some gap. Or what we do is that we just remove the data, we do some analysis, and we say that after removing some missing data, we have this kind of analysis. And mm, if we have some some relation between the previous and the future data, so basically it happens because it is not if it is, let's say, completely independent. So if completely random, or let's say, so if it something happened today and next day we just have no idea what is going to happen, then that will be random data and we cannot take any analysis of it out of it. So anyways, so missing data, basically we can fill up with the on an average, that by doing the average and all. So the basically what we can do is that right now what we will do is that we just remove the missing data and we do the mean and also basic summary. But in future you may you take advantage of some other techniques also. Okay, so okay. So there are two types from which you can see that let's say, let me say, just if I have x, which is let's say c 10, 10, 10, 12, okay. So now we know that in the third and in the sixth place there is na. So if I will write is dot na x, okay, okay. So just remove this. Okay, so you can see that it is like false, that it is not na basically not available. Then 18, then true, 13, 12, then false and false, and at that it is true. So it works for both. So basically, whenever you will have a long data set, you need to know where are the places which are NA, right? So firstly, we want to see that is there any part which are not available. Okay, but if all are false, then we can just do our analysis without doing any thing. So now if I will just write mean of x, so if you have any not available, then it will not give you the mean, for which you need to write, there are two ways. The first one is mean and x na dot rm equal to true. So if you will just say that remove all these variables and then do this. Now there is one thing, that if it is taking, when it is taking the mean, so mean is basically what, sum of the numbers and divided by the number, how many basically number of the elements. So if I will take mean of 15, 18, 13, 12. Okay. So you can see that this is also 14.5 and this is also 14.5. That means when it is removing the Na term, it is just not replacing it by 0. If it will replace it by 0, what will happen? Here 0 will come and here 0 will come. So then you can see that mean has changed. So it is basically taking out those elements, not replacing them by 0 or not replacing them by just that there was an element. So it is literally saying that you have only 4 elements. It is not saying that you have 6 elements and 2 are not available. So I'm gonna take the mean by 6. So that is one thing you need to remember. Okay. Okay. Uh, now there are complete cases. So if I will just ask, before going to that, we need to know that what is the difference between NA and null. So NA means the data is not available currently, but null is like that there was nothing. Okay, so if there was nothing in that place, then you do not want to even put anything in that place. Okay, so these two are different, basically. Okay, now the next. So the next part is that once here you can see that it is giving me that what that here we can see, just if you will have long data set, if you just know that okay, there are two places at which the data is not available, but you are not going to find like okay at which places that this is gonna happen. Or let's say here it is just 6, so you can see by eyes. Let's say if I'm giving x as 1000, which has length 1000 or 10,000, then you are not going to read false, okay, where is true, where is true. So that is one thing you do not want to do for large data set. So for that we write which is dot nax. So now it will give you the indices that okay, at third index it is there is the data is not available at third and the sixth index. So that is one thing you need to know. Now, as I have done this mean, you can perform any operation. Like you can perform the mean, you can perform the sum, maximum, or any operation just by doing this. Now, there is one thing. If I will write na dot omit x, na dot omit means omit the not available values. If I am writing this, then you can see what it is giving me, that okay, if you will omit the null values, then these are the values. The attribute, it is also giving the attribute what where are the na values, and it is also giving me the class that is. So for now, you just need to focus on these two things. The first one is that I have got my data for which I do not need to remove this. And the second one, I have got also the information where are these NA are present. If I will take mean of this, then I will get this mean correctly. But when I'm doing sorry. Okay. So, but when I'm doing this, I'm just performing the operation directly. So, if you will just write this, you will have the operation directly. But in this, you are getting uh, in this just this. If you will do this, then you are having the data as well as info about uh, NA indices. Okay, so you will have your data also, as well as you will have this NA indices. Okay, so far if anyone have any confusion they can ask. Okay, so the next one is complete dot cases x. So complete dot cases means it is like you can just see that where the data is not available, it is just opposite of what you have got here. Okay, so if data is available, then it is complete cases. If data is not available, it is false. So then you can put like you can just check by this, and there are like a lot of values to find that one. Now this one is na dot omit. If you are doing this mean x na dot rm true. So if I want to do sum, then I have to write sum x na dot rm true, and then max and then mean. A lot of work all the time, right? But where if I will just do this, that my y is na dot omit x, and if I'm putting mean of y, then I will have mean max. Like I can have everything without writing it again and again. So if you do not want to write again and again this na dot rm true and all every time, so then it is better to write na dot omit x. So it works basically better. Uh, Okay. Okay, so the missing data does not have really so much because you have just seen that how we work without uh, basically by excluding the missing data. But in future, when you work, you will have a lot of uh, work to how to replace a missing data. So that is something which is not included in this part, of course. Okay. Okay, so next we will just move directly to the control structures. So control structures basically the conditional execution. So what happens uh, whenever you are writing a long code, then there are a lot of times it happens that it may create the infinity values, it may create the zero values. Let's say you have some function where you have use of log or something like that, and you are just running a code, and at the end you are getting the error, or you are getting some result, some vague result that you do not want to use. Basically that is none of your use. So that time we use this if else condition, that okay, if this happen, then I'm going to do this. If else, then if okay this happen, then this, else this. So basically let's say if you have odd and even numbers concept. So if you have odd number, then you can do this. Just say that it is odd number. If you are doing this, then you can just say it is even number, and a lot of things. So in today's class, we will see the conditional execution, if else, nested if else, and all. Switch, which. Uh, Let me just open it one time for you. So you can see that, and in the next lectures we will start the loops. So loops, there are a lot of loops like while loop, and then for loop, etc. Okay. Okay, so now how do we write it? So firstly we give if. So if means if this happens, okay, so if this happens, then do this, and otherwise nothing. Okay, like nothing. So if it is divided by 2, print it is even. That's it, done. The next thing is that if else. So if this happened, okay, let's say if this happened, then print it is divided by 2. If it is divided by 2, just print it is even, or else print it is odd. Now what means by nested if else if? So if condition, okay, so condition satisfied, then you will have result, otherwise no result. Okay, otherwise it will not put anything. uh, Whereas in else if else, so if condition satisfied, then there is one result. Not satisfied, then there is other result. Okay, so if condition satisfied, let's say it is divided by 2, result is even. If not, then the result is it is odd. Whereas in the upper one, you are not getting any result if the condition are not satisfied. If else if. So if condition satisfy, you already know this is the answer. Else if. If condition not satisfied, that you then you need to check some other things. So then there is another condition. So when you will see in the code, it will be much more clear. But that is one thing you need to take in mind, that if one condition fails, then we are not just saying that okay, one condition failed, then put this result. If one condition fails, then we are going to check for another result, that okay, this does not happen, but does this happen also, does this happen for this case. So in that way you can just check that there is another condition. So that is, we say, nested if else, and then you can nest it as much as you want or need, until unless it is not getting so complicated that you are not able to understand what you have written. Okay. Okay. So if we are going to just start with very basic. So if I'm just writing, let's say x1 is 12. Okay. So my x1 is 12 and I'm going to check some condition on my x1. Okay. So if x greater than 4, or let's say, okay, firstly we will do when it is going to happen, and then we will see that if it is not satisfied, what will happen. Okay. So if x greater than 4, what I want to do is that I want to take square root of x. Okay. Uh, Sorry, x1. Because if condition does not apply for the length of condition greater than 1, we will see the other one, how we can use it. Okay. Uh, then, oh, sorry. I have written that if x1 greater than 4, then apply the condition on x. Then it is, let me just write it like this. Okay. So I have asked that if, you need to remember how we are writing it, okay? Because the syntax matters. So if condition needs to be given in bracket, if condition, and then what will happen if this condition satisfied. Okay. So if x1 greater than 4, then you need to take the square root of x1. If let's say I'm doing this just same, and if I will just opposite, take opposite of it. Okay. So let's say I'm saying if x1 is less than 4, then do this. So you can see that there is no result, no result. Okay, which I have written here, that if condition satisfied, then result, otherwise no result, you will not have any kind of result. So that is the if condition, that you will have no result if it is not happening. Okay. Now in the similar way, you can just take that okay, if this happened, then print this, if this happened, then print this, and all. Okay. The next is if else. So basically, if this condition satisfied, do this, else do this. Okay. So now in the second one I'm doing, because it is less than 4, so it will move to the else one. Okay. So I'm writing if x1 less than 4, then you need to do this, and so now it is important, because this is not happening in our case, we know that already. Else, if this does not happen, Then what do we want to do? You give me, if this is not happening, what condition I can give. Like, you it this way you can remember the values also. Like, can we give the ceiling function, floor function, square root, some multiplication or anything? Give me some, like, any function. Like, you know a lot of function, you know, a sine function, cos function, cot function. Like, what, like, I need to just say that if this does not happen, then do this. What is q? Where is q? Where is q here? I cannot see any q. I missed the question. Okay, so the question is basically, I have written, if this happens, then do this. Find the square root of x1. You can tell me that any function or anything. If this, I'm saying that if this happens, then do the square root of x1 else. So you can give me like what it can give. Okay, as x cube. Okay, x1. Basically, we have x1. Okay, so now you can see that if x1 less than 4, because x1 is 12, right? If x1, so it is not less than 12, so this condition phase, so you do not have any reply from here, you will have reply from else. So else x1 q. Okay, we can do other functions too. So you have sorry x1 to the power 12, x1 to the power 3. So you have x else condition reply. Okay, or we can take the sin x, sorry, sine of x1. So you can see that sine of x1, or any condition, any, sorry, condition, not condition, any operation you can give, that okay, if this does not happen, then do this. Assignment question number 5, week 5 needs to be explained. Let me see. Okay, is this the question? Okay, so I'm hoping this is the question. So we will see that yeah. So we can see that how we can write these functions, because these are basically the functions. So what you need to do is that you need to write if else condition with the functions inside of it. Here also you can do that. I mean, what is the question? Your question exactly? Okay, so next we will move to very important, which is nested if else if. So basically, this is the time when you should not be confused. Okay, so what we have is that we have if, then we have a condition, and then based on this we will have some operation or anything. We just want it that okay, do this, so execute this particular command. Okay, then we have else if. There we will give another condition, that okay, if this does not happen, then do this. Okay, and then we can do else. Okay, so this is, you can see I have nested it one time. Okay, as if one time, then you can do it like more than one time. You can do it like three times, four times. Okay. Okay, so now I will just do this. Okay, I'm just writing the conditions, and you need to give me what is the execution command. So you need to give me what is the execution command, any of the functions. So you can just revise what are the functions you have gone through till now. Okay, so let me change the condition. If x1 is divisible by 5. Okay, okay. So we can see that it is not divisible by 5. You can remember this is the sign to find the remainder. Okay, so if remainder is not 0, that means it is not divisible by 5. Anyways, if it is not happening, then give me some command to execute, like I have written here, here, anywhere. Give me any command. Okay, 2x, very simple. I will just appreciate it if you will try some better ones, so that you can remember. Okay, let's say you can remember the absolute function, you can remember the square root, the trigonometric functions, and what else? There will be a lot of it. Okay. Anyways, uh, now if this does not happen, then as if. So if it is not divisible by 5, then uh, check if it is divisible by 7. Okay. Okay, then give me another condition. Other people can also contribute to it. Cos x. Okay. So we have cos x1. Okay, right? Now if this also does not satisfy, then we will have another one. So let's say I'm just writing it. So I'm writing ceiling of square root of x1. Okay. What is the problem? Uh, okay, sorry, x1. Okay. So you can see it is 4. Why? Because uh, if I will run up to this, then you can see there is no answer. Why? Because it is not divisible by 5. So it is not going to give us any result. If I will run it up to this, then also there is no answer. Why? Because I have not given the end part. So it is saying that you have checked if this does not happen, so no result. Then you have also checked if it is divisible by 7. Then also it is not divisible by 7, so we do not have any answer. Then at the end, I have said that okay, if nothing happens, if this and this no condition is happening, then give me this result. Okay, so you can see that this is 4. So if I'm running the whole line, then I will have this last one result. Okay, but if I will do this, okay, it is divisible by 6, so we know it is divisible by 6. If I will give this command, then you can see The answer is 0.84, which is the cos of x1. So cos of x1. It is saying that okay, this does not satisfy, but this satisfies. So I'm just writing both. So you can just, when you will go through this, you can just see. If I will just remove all of it, then you can see. So in the first one, two condition phase, so you have the answer of last one. In this one condition phase, second condition satisfied, so you have the answer of second one. So at whatever place your condition satisfied, it will just give the answer of that, and it will just not, the later part will be useless for it. Okay. Okay, so till now, if anyone have any doubt, you can ask. Uh, for the, like, till now, if you have not practiced for this, some, basically some values and also, then it is all fine that the functions you can remember at the end. But the place where we start the condition and matrices also, and the loop, basically the loop is very important. I don't know, whatever we do, we mostly need the loops for this. So you need to practice for that, because how to write and all, you may do some mistakes, because you can just put the comma and all, something else. Okay, the next is if else. So till now, what we have seen that if else, nested if else, these are all working. But if the the time I just write here x, it is saying that this is greater than. So nobody has that much of time that they will just do it for one, right? So x1 is just 12. So we already know what is the things with it. We already know that okay, it is divisible, not divisible, and all. So if you do, then what we can do is that we can either make a for loop. Okay, first thing is we can make a for loop, and then I can just say that x, we have x, we have x1. Okay, so I can just say that okay, for I 1 2 up to 6, x1, x2, x3, and then you can check the condition one by one, like this, for all the values. Otherwise, just for one value, nobody is going to do this much of efforts, which you can see just by eyes. Okay, the next is if else, test, where you have test and you will have yes or no. Now this works for uh, more also. Okay, so now we will perform this operation on x as well as x1. So if else, okay, okay. Let me just write this only. Okay. Uh, So rather than this execution, we will have to x, otherwise also x. Okay. So if else condition is basically if this is divisible by 5, then do this, otherwise do this. So since it is not divisible by 5, it is the answer. Now if I will just write the same, uh, but doing for x rather than x1. So the places where there are NA, there is NA, we cannot do anything. Now the x is 15, so 15 is divisible by 5. So if this is divisible by 5, then do it like 30, so do it multiplied by 2, so it is 30. 18 is not divisible by 5, so there is cos of 18. There is cos of 80, which is this. Now for the NA, it is not doing anything, we cannot do anything. 13, 12, same. So 13 and 12 both are not divisible by this one. So you will have this result. If I will just change the condition, because most of it you can see that are divisible by 3. So if I will put 3, then you can see that this 15, 18, both divisible by 3, so multiply, so 15 times 2, so it is 30, 36. Now this one is the only value which is not divisible by 3, so you have the cos of 13, and here also it is 24. So you can apply the if else. You can see that for if else there is no condition that you need to have the length 1. You can put it on any length. Okay. Okay. So if there is anyone who has any doubt, you can just ask. Now, very, very this one, that if it is divisible by 2, we have even number, and then if not, we have odd number. So you can see the first one, this one is odd, this one is even, not available. 13 is taken in radian. uh okay. uh 13 degree, no, 13 is taken as value. When I say value, that means you have the pi. So the pi is 3.14, right? So if I'm just writing cos pi, it is minus 1. So in that way. So if you will write cos 13, then it will be, you need to calculate how many times pi it is. So let's say 13 by pi. So it is 4 point something. So it is basically 4 pi and then something greater than this. So you will have this graph. So I have already shown in one of the classes when we have done this trigonometry. Uh, Not in this, I think. In this. Oh yeah, right here. So you can see that it is for the sine. Now, yes. Uh, where I put, I don't remember where I put, yes, from here. So it is for the sine. So you have 0 to pi, and then 2 pi, and then 3 pi, 5 pi, whatsoever it is. So according to that, it will take. It will not take in the radian. It will take as a value. Okay. What is the discrepancy in the assignment question? See, whatsoever have you have discrepancy in the assignment, you need to write it in the discussion form. I have told you already, because I'm not the TA of that. I'm just TA for the tutorial session. So if you will have any doubt or regarding that assignment is not correct and all, then the Prashant sir can reply only, because He is the one who is going to check and all. So you can just write in the forum that this is the problem, and then you will have the answer from there. Okay. Uh, okay. Okay. I mean, I don't know. Like, I cannot do anything because I do not have any contact with him. So maybe you need to write it again. Let me see. This. See, he always replies like on time. So, uh, someone has written already. So he has already replied. We will check for any other. Okay. So you need to go through this again and again. So he has already replied. So no, you do not need to do this. You can just go through the column and see you have some doubt in question fifth. So okay, so this is for assign week 6 or something like that. So you, if you will just ask, then he replies very fast. I think. So this is August 25, and he has already replied for the previous. So if you will have any doubts, you need to write it here, and then he replies. See. So you need to write it here, and he always replies. So that is not one thing. Okay. All you need to do is that just join this group and then write it there. There is no email ID. That's what I'm saying. There is no email ID. You need to write this. When you log in, when you join this course, you will have this discussion form, and there you need to write it. There is no email ID for it separately. Here you will have this, where you will have this assignments about the course, and in QA you are being directed to Google discussion form. And if you will just continue to this, you will have all this, and you can just join the group. I have not joined it, so you can just join the group and then just write a question. Okay, so there is no separate email ID for that. Okay, so we have gone through if else, nested if else, and if else testing. uh, we have done some examples. So okay, so we can do some examples, and then we will move to our next topic, which is switch and which. Okay, so what do you think will be the answer of first one? Any, right? So you need to see just, it is just that you have seen. So na.rm. So it is saying that na, so basically na not available dot rm. So remove. So you remove the not available values, which is giving as false. So if I will not remove these values, then it is giving me, so we will have basically this value. So it will give me the na. The next is, suppose x is any vector as x is equal to c, this, and if I'm putting this na dot rm true, what will happen? Sorry, there is Okay. If I'm writing na.rm as true, then what will happen? Yes, you will have the mean after removing the na, but what will be its mean? See, when you are having the class, then you should be on your laptop. Okay. So you can just execute the commands by yourself. You can just do this because otherwise you're just going to forget everything. You will not remember whether you need to write na.omit firstly or you need to write x na.omit or na.rm. Where are the things you need to put if you will not practice enough? Okay, so let us just write it. Okay. Okay, so y is x 10 to 20, 35, 40. Sorry, C. Okay. Uh, Now we need to find the mean of y1. Okay, good. Na dot rm equal to true. So this is the mean. So basically it has taken firstly then 10 to 20 and then 35 and then 40 around. So the answer is the first one. Okay, the next. So the next is you do not need to calculate, you just need to think. Same. Okay, so you will have the same answer because na dot omit x, that means omit all the not available values, and then you will have the same answer. Okay, the next one is that we have started with if else. So if this happen, else. If this happen, then do this, else this. So x is 12. It is saying if it is equal to 12, then we need to do this. So because it is equal to 12, then x square would be 144 minus 12. So it is 132. Okay. The next one is if else. If else, you can see that there's a difference. There's if else or else space if. But here there is no space, there is just else if. So if it is less than 12, then do this, otherwise do this. So this is going to apply on the whole. So you just need to see the first, okay, and because all are different. So whichever where the first one is true, that will be the answer. Option D. Okay. So x is less than 12. So 2 is less than 12. It is true. If it is true, then it is 2 minus 2. So it is 0. So let us just see for the next also. So 14. So 14 is not less than 12. So it will be, it is a no. So it is a no. So that means 14 plus 2, 16. So you can see this is the correct answer. Okay. Now this is basically the correct syntax. So that is you need to write that if this happens and since It is just opposite. So if x is not less than equal to 0, what will be the x? X will be greater than 0. That is obvious. So you do not need to write if else and then if and then else if. So you do not need else if. You can just write if and then here else. So that is the fun thing. Okay, the next thing is that you need to write if x less than equal to 0. So if x less than equal to 0, you can see all are there. The next thing is that brackets. Okay, so you need to see that these are the brackets we give for this. So even if you do not go through the expression, then you can see. Uh, Otherwise, you can just use this also. Okay, so the expression is, I mean, you do not need to solve for whole. You can just see this one. 2x, so 2 multiply by x to the power uh, to the power 7 by 2. So you can see that these and these are not correct firstly. Okay, so you will have the option from this and this. Now this one is absolutely x to the x cube minus 33, else y equal to 4 multiplied by this plus square root of x to the power 9 by 2, and you can see all of it here. Whatsoever is not clear regarding the assignment, you need to write it in the discussion form, and I cannot do anything in that. Okay, if it is not clear, if you think there is some ambiguity, then you need to write it there, because I do not check it. Okay, now in this, what you okay, fourth root. What is fourth root? Is it in the assignment, the fourth root or something? Yeah, so in this x greater than 0, so if x less than 0, so first and so this are not going to happen. In first and second, something can happen. So this, you have this. Yeah, so write this is square root. I mean, if in both this, you know that there is only because of this, what to say, basically, uh, you know, this is working and this is not working, right? So you know that there are two types of brackets. We can use the curly one and this one. Now here you can see that it can be the first and second. So you need to see that which brackets we can use and just put it like that. So it is written 4 and it is not giving here. So out of this, whatsoever suits most suitable basically. So you need to tick on that. You do not need to see that okay square, this is fourth root, but if it is not given here, then just click what do you think it best suitable for this. Okay, if there is any problem in the question, then marks will be given on that basis, right? So just whatever suits better, just tick on that. Okay, the next we have the questions based on switch and which. So that we have not covered yet. So switch. Uh, so switch is basically if you will have some expression. So switch basically what happens. We just do this that okay this happens, then just go to that place. Okay. So this is something happens with switch and which. So which is we already know. Which is we already know that which is dot na true or and all. So which we already know that okay at which place this is happening, or at which basically element or something like that whatsoever you want to say this is happening. Okay, so that you can give. So basically in the which you get the indices, in the switch you give the index that you need to switch to that index. Okay, uh, if I will give a switch. Okay, then if I will tell it to go to this. Okay. Okay, let's say what will happen if I will just write randomly some this. So it is not that it is going to work on only characters, but what is the important thing here? You will get confused. So let us start with uh, writing like this. So 3, 1, 3, 4, 5. Okay, so now you know that the first, this one, what it is doing, it is the first one, the first one, this one. This one is telling you where you need to go. Okay, so when I'm writing like the above one, you do not need know like what is this, just some random numbers. But here you can see that third, I'm writing third. So switch to third element. So third element, so the data starts from this. Here also it is same. So this one, this three, this one is the index. It is telling you where you need to go, and then from here data starts. So you are going to first element, second element, and third element. So third element is the answer. Here also it is same. So you are saying that switch to third element. First, second, third element. So the fourth is answer. But if you will write like this, the like first one, you need to remember that you need to leave the first one. That is the index where you need to switch, and then the later part is your reply. Now, this one is basically just moving to one, basically one index. Okay. Now, rather than moving to one index, let's say I have a lot of, let's say there is a data frame where there are a lot of columns. Okay, so let's say it is regarding the students. Okay, so of 10th 12th class or graduation or any. So I will have their name, their let's say 10th mark sheet, and a lot of information about that person, the gender. So for that, we can switch to one column. So let's say switch, and I'm switching to, let's say, marks. Okay. Now I will write the marks. Sorry, I need to write the name firstly. So name. So name is, let's say, LP. Okay, any random, and I'm writing gender. Sorry, that I need to give it like this. Gender as female, and the marks is 12. So you can see that it is giving me the marks. So if I have, let's say, 3 4 information about a person, then I will have this. If rather than marks I will write name, then it will give me the name. So it will move to, basically, if you will have a column, then it will just move to that. Okay. If I will just write, then you can see that it will give me the whole also. Uh, let's see if we can do this. Okay, so try this. I will write name 1. Then it is not giving like this. So it is giving us the whole vector. That also you need to remember. Okay, so that is one thing regarding the switch. So the first thing is that how you can switch. You can switch either to just name, or like, sorry, you can either just switch by doing the indices, or you can switch by giving some information about some. Okay. Uh, right now I am just removing it so that it will be one person, one gender, and one marks. Uh, Fine. So next we have is which. So which function, so indices in which particularly command will satisfy. One more thing, what will happen if you will give something which is not present? Okay. So let's say its name is present and its gender, marks, uh, but let's say it's uh, percentage. The percentage is not present. Then it will not give you any result because the percentage is not present. So that you need to see that if some there is command which you are giving to switch, and let's say it will go to this place, find it. Okay, this is not here. Okay, this is not here. Okay, this is not here. But if it is nowhere, then it will not give any result. Okay, whereas which, so which we already know that which, that means at which places it is happening. So it is basically just by you, it just by its name you can understand. So switch is basically go to that place, and which is basically at which place this is happening. Okay, so now which. In the which condition, so we have data. So let's say I'm writing for y1. So at which y1 it is, let's say I'm writing 16. So it is giving me 7. Why? Because if I will just run, you can see y1 is 10 to 20, 35, 40. The Y1 is 10, 11, 12, 13, 14, 15, 16. So at which place it is 16? This place. Index is 0, 1, sorry, index is 1. So 1, 2, 3, 4, 5, 6, 7. So at the seventh place, Y1 is equal to 16. Just okay. So this is the place where it is 16. Now we can do a lot of like basically calculation based on this. So we can see that uh, which of the y1 is divisible by, let's say, 12. Okay, so it is giving me third because third is the only place. If I will just write 6, so you can see 3 and 9 because at the ninth place there is 18. So 6 and 19 are divisible by 6. So these are the indices it is giving that, okay, at this place and at this place. So is it like clear or is there any doubt or something? Maybe I'm going too fast. Okay, so I will just write. So y1, so this one not divisible by 6, not divisible by 6, divisible by 6. Its place is 3. This one not divisible, not divisible, not divisible, not divisible, not divisible, divisible. Then it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth place. And then it is not divisible, not divisible, not divisible, not divisible, and these are not available values. So this is basically the which command, that okay, at which places this is happening. Now, if I will write which dot max y1, so it is giving me 13. So 13 is not the answer. It is the answer that at 13th index it is maximum. So if you will write like this, so let us do this on x because it is just given directly. So if I will write which dot max x, so you can see 18 is the maximum. So second index, it is saying that at second index it is this. Now how you can find what is the maximum value? You need to write x which dot max x. So you will see that means you are saying x and which dot max is what? 2, x2. So you wish dot max will give you the index, and then you will write x. What is the x value at that index? So x value at second index. So this is 18. So by which dot max you will find what is the index, and by x which dot max you will find the maximum value. So let me just write it. Okay, you can find the index of maximum value, and by doing this you will find maximum value. Similarly, we can do this which dot min x. Okay, so this is fifth place, it is minimum. Then I need to write x which dot min x. So it is saying that it is 12 and it is at the fifth place. Okay, any doubt till now? Okay, good. Okay, so next we can see some examples and then we will see because mm, if I will go to this lecture, running, I'm just
Similarly, in case if you try to take it is at the location right,
okay.
and
So you can see that it is explained for the matrix also, and for matrix there are some. So we will do that after doing this some example. Where is this gone? Okay, I don't know how, but it it has deleted. No, okay. So this is okay. Excellent. Okay, okay. So this is the example. You need to switch option C, right? So we start the indices after the first one because this is the index where we need to go. So this is 1, 2, 3, 4, 5, 6, 7. So it is saying switch to second. So second is journal. Okay. The next one is so it is 7. So 1, 2, 3, 4, 5, 6, 7. The seventh is this one. And now it is saying uh, that rather than indices, we have moved that, okay, go to this column or something like that. So it is saying that you need to switch to S3. HK, right? So this one, very simple. Okay, now this one, you have X and it is saying that which X equal to 120. So it will be like 1, 2, 3, 4, 5. So it is the fifth index when it is equal to 120. Okay. So now we will do this two matrix so that we can understand that because right now it is just giving the index like this. But when we go to the matrix, then how we will read those indices that matters. Okay. Okay, so let us just create a matrix. So let us say Z is my matrix in row is so okay in row. Let's say I have. Do I have the last one? Okay, okay. I'm just copying the last one. Z1 and Z. So Z1 is my data and uh, I'm creating the matrix by this. So Z is my matrix. Now I'm saying that which Z are divisible by 0. So you can see that it is giving me this result. Okay, that 1 and then it is saying that 5. Okay, so data is like this 1, 2, but it is not giving based on the data. It is giving as the matrix is giving. Okay, let me just copy all this. Okay, because this is important. You can see that if it will give according to the data, which should be 1, 2, and then 3, 4, 5, or something like that. But which is 1, 1, 5, 6, 7, right? So why? Because it is going this direction. First row, second row, third row. So this one is basically this place, right? The first one is 20, then second place, third place, fourth place. This one is fifth place for it, 18. So basically, it is this, and then fifth place is this. Then this is the sixth place, this is the seventh place. So you can see 8, 8. Then 8, 9, 10. Then this is the 11th place. 12, 13, 14. This is the 15th place. Then 16, then this is the 17th place, 18, then 19, and then 20, right? So these are the values. So, okay, so um, I have these are just values. Okay, so you can see that this is very different. Why? Because if I will just do a basic thing, if I will just do uh, let me write it as Z2. If I will just do this and do, then it still follow column sequences. Yes. If I will just do this and write which Z2, then you can see that it is now different, because now Z2 it is 1, 2, then this is 5, then this is 7. So you can see that the indices are completely different. So you do not need to find which indices. You do not need to go this and this. If you will have a very long, let's say, matrix, let's say 1000 by 1000, you are not going to go, okay, this one is 1000, so this one is 1001, then 2000, then 2002, and all, right? So for this, what we do is that we write which z uh, divisible by 2, or let's say the z2, and then r dot int is true. So now you can see r dot int, that means index is true. So now you can see that it is saying uh, first row, first column, second row, first column, first row, second column. So rather than giving it as 5, rather than giving it as 5, because it is 1, 2, 3, 4, and this is the fifth value. So rather than giving it as 5, it is saying that it is first row, second column, right? And then 7. So 7 is this. So it is saying it is third row, second column. So this is uh, more better. So you can understand better. So if uh, I will just run this and this. So from here, you need to see the matrix, and you need to go through this addition: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14, 15, 20. Yes, what is the problem? You have raised hand, so if you have any problem, you can just say, or you can just write it in the message. Okay, so when we are doing the first one, then you need to write this, but in the second one you will have the indices, that which place what is happening. Okay, so this is very important. Okay. Okay, so up to this we need to cover. In the next class we will start with the loops, and starting will be with the for loop, while loop, functions and all. Okay. Okay, so this is more or less regarding the today's class, and if anyone have any doubt you can ask regarding the class. Function statement fx equal to. Okay, so I did not get exactly your question. You can unmute yourself and you can ask, or otherwise you need to write a bit properly that what I need to, what you are asking exactly.
How to calculate the exponential value in R. Just write it like this.
You need to write exponential of 3. You will have this exponential. For most of it, there are already this. So if you will have log, you can see then there is log 10. So if you will just write log 12, let's say, you will have this. If you will write log 10, 12. So in general, log is basically with this. Uh, uh, okay. No. So this is for the base 10. This is for the base e. So you most of this already are defined. So exponential, logarithmic, trigonometric, most of the functions are already defined. 13 of the assignment. 13 of which assignment? Fifth or sixth? Assignment 12, please explain. Mm, assignment. Okay, so firstly, which week? Which week? Is it fifth? Okay, let me just. Okay, this one. Okay, so you have z function of xy, x square, x square plus 2y plus this and this. Okay, so what do you have? Uh, Let me see what you are all asking. This is two function. No, this is one function. This is one function zxy. Uh, Question 13 and 12. Okay, so 13 and 12. So this is basically one function. The function is of x and y parameters. So sim, the simple way basically when you write, let's say fx, if I'm writing fx as x plus 1. So what will be f2? It will be 3, right? So this is one function. So now fx is dependent only on x. here, because see, I cannot solve assignments for you, okay, because this is the place where you get the marks, so I will do some similar example. Now here, what is the function? It is of 2. So if I'm writing z, so you can write it y. If I'm writing z as fxy, so that means z is function of two variables. Here you can see this is the function of one variable. Basically we say as independent and dependent. So basically we say that this is depending on this. So y is depending on x. So if I will change x value, then y value will change. Uh, Now if it is like this, so it is function of two variables. So z is function of two variables x comma y. That means z is depending on 2. So if I will write z is equal to fxy, and it is, let's say, x square plus 5 cube minus 3y. Let's say this is z. Okay. So what will be z11? Z11 will be, put x as 1, y as 1. So it will be 1 square plus 1 cube minus 3 times 1. So it will be 1 plus 1 minus 3 minus 1. Correct? Right? So that is all you need to do. You need to just write that, okay, this is the function of x, y, and then 1, 1. So you need to put x 1 here, so it will be 1, and then for y also you need to put 1, and then you need to solve it. Okay, is it clear now? 13 question. Y, so you have two values here, right? Yes. Okay, so yes. Okay, someone else also asked regarding the question 12. So in the question 12 also, what you have, you have y, and here you have two variables x and y, and z is depending on x and y. Here you have y which is only depending on x. So when x is 2, so just put the value 2. When x is 2, you need to just calculate it. Okay, so you know how to calculate exponential. You need to write exponential of 2. You need to write 2 times 2, and you need to write 2 square, and that's it. But we create the function so that do not need to put it again and again, right? Here I am putting it again and again, but in the R I will say this is my function, and I will just give it this. So he, that basically he, basically the R will do all the calculations for you. So whenever you need to perform a operation again and again, we make it like a function, and we say we give the different values to it, and it will just do it. So let's say you have the data, let's say of 5 columns, and you need to do the same for all the 5 columns. Then you create a function, and you just give that, okay, I'm giving first column, do this, I'm giving second column, do this. Okay. Okay. Okay, is there any other doubt? Okay. Okay, so is there any doubt regarding today's class or previous classes? Then you can ask. Uh, Otherwise, we will just quickly revise what we have done for today's class. Okay. Okay, so first thing, what we have done uh, here. So first thing, we have started with mean value. Now there are two values to omit these values. One is na.rm, second is na.omit. If you are using na.rm is equal to true, you need to write it again and again, right? Whereas for na.omit, so you need to write na.rm if you are doing the mean, addition, maximum, anything. I think maximum can be done without that also, but you need to write it again basically for finding this. Whereas if you are writing na.omit, then you can just save the after removing these values, you can just save it in a variable, and then you can just perform all the operations on it. So you do not need to write it again and again. Okay. The next thing also, that na.omit gives you information regarding the values which are available, so which are already there, and also the index. It also provides you the index which are at which places it is the data is not available. Okay. The next thing what we have is that we have seen the complete cases. So where the data is available, it is complete cases. After that, we have moved to if else, nested if else if. The first one if condition satisfied, result; if not, no result. If else, if condition satisfy this result, if not satisfied, then you will have another result. If else if the condition satisfied, you have one result, else you apply another condition. If that another condition satisfied, you have one result, else you will have another result. So this is basically some example of it. The next we move to if else. Now, if else, if else, if else. All these works only just for one value. Next, if else. So if else is condition. If yes, first answer. If no, second answer. So this one is condition. If satisfied, first answer. If not, second answer. For all the values. It goes for data vector or the scalar value both. The next, we have seen how we can work with this switch command. So switches first, whatever value you will see 3, 2, 1, 7, etc. That is the index you need to go. And from the second value, you will start counting the index. So from here, you will start counting the index, and this is the place where you need to go. Similar happens if you will give in place of just values, if you will give some, uh, let's say, data frames, value, or column names, something like that. Next one is which. So, which is at what place this is happening. So, which will give you the index. This is the way to getting the index. If you will write x in bracket this, so which is giving you index. So x in bracket that index. So it will give you the value. Okay, the next we have gone through for the matrix, and for matrix we have seen that if I'm saying array dot index true, then it is giving me row and column, and if it is false, then it is just giving me the places, and which is counted like this: 1 2 3 4 5 6 7 8 9 10 11 12, like this. It always counts like this, not like this. Okay, so this is so far we have covered for today's class. Okay, if till now anyone has any doubt, you can ask. Uh, okay, so this is week 5, which means location. Yeah, exactly. So location. So what is its location? So in R or in the codes, basically we say which is the index. What is the index? Okay, so if there are no doubts, then I'm ending the class. Okay, thank you all for joining this class, and hope to see you in the next class too. And it is just you need to go through all this, and you need to just start writing these quotes on your own, okay, without saying. Okay, okay, thank you. Bye bye.